Hello everyone, myself Charan MB and I am going to give you a presentation on cryogenic grinding. Contents: Introduction, Application of cryogenics, Problems faced in conventional grinding, Cryogenic grinding technology, Working principle of cryo grinder, Performance data and technical data of cryogenic grinding, Field of application, Superiority of cryogenic grinder over conventional grinder, Merits and demerits of cryogenic grinder, and finally the conclusion. Introduction to cryogenics. The term cryogenics originates from Greek word which means creation or production by means of cold. Cryogenics is the study of very low temperature or the production of the same. Liquid nitrogen is the most commonly used element in cryogenics and is legally purchasable around the world. Cryogenic grinding technology can efficiently grind most tough materials, can also facilitate cryogenic recycling of tough composite materials and multi-component scrap. The cryogenic process also has a unique capability for recycling difficult to separate composite materials. Now, application of cryogenics. Biology for preservation and in treatment of diseases. Food industry for food handling and processing. Electronics. Inert production areas and microchip testers. Metallurgy to remove residual stresses and to improve wear resistance. Aerospace cooling of jet engines and in-flight components. Problems faced in conventional grinding process: high heat generation, introduction of tensile residual stress, less tool life, clogging and gumming of the mill, oxidation, and loss of etheric oil in spice grinding. Here comes the necessity of cryogenic grinding, also known as freeze grinding. Cryogenic grinding technology. Cryogenic grinding, also known as freezer milling or freezer grinding, is the act of cooling or chilling a material below its embrittlement temperature and then reducing it into a small particle size. Typically, liquid nitrogen or in certain applications, liquid carbon dioxide is used. After cooling, the material is fed into an impact mill where it is reduced in size primarily by brittle fracture. For pulverizing many materials, cryogenic grinding technology increases productivity and lower power consumption. Many elastic or soft materials are difficult to pulverize using conventional grinding. In such cases, cryogenic grinding is used. Working of a cryo grinder. Material is to be ground, is cleaned manually and fed into the hopper. From the exit of the hopper, the material enters into the vibrating feeder, which is positioned with a small inclination towards the entry of the helical screw conveyor. Liquid nitrogen from the storage container is sprayed into the screw conveyor. The time of stay of material in the conveyor can be maintained by varying the speed of the drive. The sensor monitors material's temperature in the conveyor. When the mill is running, the material gets crushed between the studs and comes out through an optional sieve as a ground product. To the bottom of the mill, a collecting bin is housed where the ground product is collected. The vaporized nitrogen from the mill is sucked by a centrifugal blower and through the filter assembly is fed back to the mill and the cycling process is continued. This is the schematic representation of a cryogenic grinder. Now let's take a look at the working process of the cryogenic grinder. Performance data and technical data. Performance data. Field of application, size reduction and homogenization. Feed material, any type of hard, brittle or soft material can be grounded easily. Feed size, up to 8 mm. Final finish, approx 5 microns. Batch volume, maximum of 20 ml. Mean grinding time, pre-cooling of 10 minutes and grinding of 1 minute. Technical data, power consumption of 160 watts and net weight of approximately 46 kgs. Properties of liquid nitrogen as a working fluid. It is produced by separation of air into its components in an air separation plant and is distributed in vacuum insulated transport vessels to the end user. Physical properties: inert, colorless, odorless, non-corrosive, non-flammable, and extremely cold. Chemical properties: molecular weight of 14 gram per mole, boiling point of -195 degrees Celsius, and a melting point of -210 degrees Celsius. Density of 1.25 gram per liter. Health effects: excessive amounts can cause vomiting and loss of consciousness. Factors affecting liquid nitrogen consumption in cryogenic grinding: ambient temperature, size of raw material, type of mill, type of cooling, production rate, stop and go operation, moisture content, oversized backfeed, and final size are the factors affecting the liquid nitrogen consumption in cryogenic grinding. Advantages of cryogenic grinding with liquid nitrogen: higher retention of etheric oils, prevention of oxidation and rancidity, increased throughput and power saving, final particle size, reduction in microbial load, possibility of fine grinding of difficult spices. Fields of application: cryogrinding of steel. The large amount of heat is generated during machining or grinding at high speed and feed rises the temperature at cutting zones excessively. To overcome this problem, liquid nitrogen is fed to the grinding spot. Thermoplastics and thermosets. Fine thermoplastic powders can be made by cryogenic grinding. Adhesives and waxes. To avoid pliable and stickiness of certain materials, cryogenic grinding is used. Explosives. To grind the explosive materials below their ignition temperature. Spices. To overcome the volatility of etheric oils. Superiority of cryogenics over standard grinding system. Traditional grinding system and cryogenic grinding system. The heat is developed inside the grinding mill. The temperature is below 0 degrees Celsius. Essential volume of material are evaporated. No evaporation of essential value. This in turn can lead to grinding elements becoming greasy and even harms the machine by blocking it. Not in cryogenic process. High energy consumption, low energy consumption. High capacity motors are required to grind the material. Low capacity motors are required to grind the material. No control on particle size. Particle size are under control. This is the graph showing the particle size comparison between the cryo mill and the standard mill. Merits: ability to process soft or elastic material, high production rate, fine particle size, no heat generation, prevents oxidation, minimal loss of volatile component, more uniform particle distribution, lower grinding cost, and lower power consumption are the advantages of cryogenic grinder. And demerits of cryogenic grinder: high operation cost, maintenance cost is above the range, filtering of screw conveyor is difficult, it is dangerous to store and handle cryogenic gases. Conclusion: as the cost of raw materials and energy is increasing day by day, it is very necessary to use optimum quantity and at the same time getting the required quality. By using cryo grinding technology, these aspects can be met effectively. By using this, we can also recycle tough and composite materials. It has many significant advantages over conventional grinding. This also leads to value addition to the product. Cryogenic grinding is economically viable if liquid nitrogen costs are not formidable. Thank you guys.